evening, Teacher Joan Kawagan. By the way, I am Don Kelly Pagubo from grade 11 STEM Rubidium. And now, let's going to tackle the Lewis structure of potassium and sulfur, the OF2, and the C4H8. So what are you waiting for? Let's get started. Sulfur and potassium is an ionic band. Sulfur is a non-metal, while potassium is a metal. The combination of a non-metal and a metal will produce an ionic band. On the periodic table, potassium has one valence electron. However, sulfur has a 6 valence electrons. Potassium has one valence electron, so we need to put one dot out there. And sulfur has 6 valence electron, so we need to put 6. 1, 2, 3, 4, 5, and 6. As we copy the situation above where potassium has one valence electron while sulfur has 6 valence electrons. Potassium will give electrons to the sulfur because metals are likely gives electrons to non-metals. But because potassium gives electrons to the sulfur, it meant to gain a positive charge. However, the sulfur that has given electron by the potassium will have a negative charge because it adapts the electrons of the potassium. OF2 is being called oxygen difluoride. They are covalent bands because they are both non-metal. We have one oxygen atom while fluorine has 2 fluorine atoms. Oxygen has 6 valence electrons. However, fluorine has 7 valence electrons. So multiply one oxygen atom and 6 valence electrons and equates to 6. We also multiply 2 fluorine atom and 7 valence electrons and equates to 14. 6 plus 14 equals 20 valence electrons. We'll place oxygen atom at the center because it has less electromagnetic than fluorine, so fluorine will be put at the side of the oxygen. After that, we'll place one band between oxygen and fluorine to show the band formation. Then, we'll put 6 valence electrons to the fluorine and 6 valence electrons to the other side of the fluorine, and 4 valence electrons on the oxygen to satisfy a perfect total of 20 valence electrons. So it is the formation of the oxygen difluoride Lewis structure. The last one is the C4H8. C4H8 is a covalent band because they are both nonmetals. Carbon has 4 carbon atoms, while hydrogen has 8 carbon atoms. Carbon has 4 valence electrons. However, hydrogen has 1 valence electrons. We need to multiply them all and add them all to get the total valence electrons. 4 valence electron multiplied by 4 carbon atom equals 16. 1 valence electron multiplied by 8 hydrogen carbon equals 8. So 16 plus 8 equals 24 valence electrons. Then we'll place carbon in the center because it has less electromagnetic than hydrogen. We have 4 carbon out there. And now, we're going to put all the bands that fits together to form a perfect Lewis structure. We need to have at least 12 bands in order to get the perfect 24 valence electrons. After putting all the bands, we need to put all our hydrogen to satisfy a perfect Lewis structure. We have H there, H also there, hydrogen there, hydrogen also. We have hydrogen, hydrogen, and the last hydrogen. Then count off all the bonds together. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. The perfect valence electron. And now, it is the formation of the C4H4 Lewis structure. I hope you've learned something in this video. Happy learning!